Good morning, Blue Streaks. It is Wednesday, May 6th, and this is the last lesson I will have for you to videotape, the last thing we're going to learn. And then Monday, next Monday coming up, we'll give you a practice quiz. And next Wednesday will be your final quiz of your senior year in CPMath. So congratulations, graduates, for your hard work. I appreciate all you did in CP this year. Thank you for your efforts. I hope you're all healthy and safe. And I just wanted to start today by doing a couple problems from homework just to make sure we understood finding the first three terms of a sequence, whether it be a normal or a recursive rule. And then we'll work on today's lesson. So what I'd like to go over is number 3 and 5. Okay, so for number 3, we got a sub n, the nth term equals -1 to the n plus 1 power divided by n to the second power. So remember, n represents which term we're looking for. Since we're looking for the first three terms, we're going to look for term 1, term 2, and term 3. Okay, so for number 3, all right, the first term, a1, would be -1, is always in parentheses for this rule, and then it's to the n plus 1 power. So n is 1 in this one, so the 1 plus 1 power over, and again, n squared, and again, n is 1. So that's 1 squared. Okay, so that'd be -1 to the 1 plus 1, or -1 to the second power, which is +1, -1 times -1, and over 1 squared, which is 1. So the first term is 1. For the second term, a2, it's still -1 in parentheses. And then it's n is 2. All right, look, n is 2 for the second term. So I put 2 here and here. All right, so -1 to the 2 plus 1 power over, now n is 2 over 2 squared. Well, that's 2 plus 1 is 3. -1 to the third is -1 times -1 times -1, which is actually -1. Some of you forgot that on your homework. And then 2 times 2, or 2 squared, is 4. So the second term is -1/4. And then the third term, a3, means we're going to put 3 in for n. So remember, it's still -1. It's in parentheses every time. And n is 3, so n plus 1 would be 3 plus 1 over n squared. And again, n is 3 for this term. Third term, n is 3. So that's how I would substitute. So now it's -1 to the fourth power, which is -1 times -1 times -1 times -1. Remember, would be a +1. 4 negatives. Even number of negatives is positive. Odd number of negatives is negative. So when we have the quiz next week, pay attention to your signs. And then 3 squared is 9. So our three terms are 1, -1/4, and 1/9. All right. First term, we put 1 in for n. Second term, we put 2 in for n. Third term, we put 3 in for n. We were using number 3 here. Okay, using that rule. All right, I'd like to do number 5 as well. This is a recursive one where we always give you the first term, a1, and then figure out the second and third term. Some of you found the second, third, and fourth. That's okay, but I was always only asking for the first 3. All right, so number 5, first term was 2, I believe. Yeah, so we got that. And then the nth term was equal to n times a to the n minus 1. Remember, a sub n minus 1, when you see that, it looks better up here. When you see this, that means the previous term, the term before. Okay? So I got the first term. So for the second term, n would be 2. Remember, n represents which term we're looking for. So for the second term, n is 2 times the previous term. Well, the previous term in this sequence is the first term, which would be 2. So 2 times 2 is 4. So that's my second term. My third term, n is 3. So I put a 3 in place of the n times, again, a sub n minus 1. Again, that subscript means the previous term. Okay? The previous term, second term, is the one before the third, was a 4. So it's 3 times 4, which would be 12. So the first 3 terms of number 5 is 2, which we gave you. Second term is 4, third term is 12. Okay, so I just wanted to review that real quick with you from what we did on Monday. So hopefully that's helping you if you made some mistakes. Some of you were making a few mistakes when I was looking at your homework. All right, so today we're going to talk about sequence and summation. All right, so summation is when we add up the terms of the sequence, okay? So before we do that, I want to talk to you about this symbol. The factorial symbol is the exclamation point, okay? And what that means is this. My example is 5 factorial. That means 5 times 4 times 3 times 2 times 1, which is 120. Okay, that's when you see that symbol after a number, it means multiply all the numbers down till you get to the 1. So if it was 100 factorial, it'd be 100 times 99 times 98 times 97, all the way down to 1. Okay. Now, there is a button that we can push on our calculator to do that. All right. So you hit your 5, and then you hit your math button, which we've done a lot, but you move over 1 to the right to numbers. Actually, I lied. You go 3 to the right to probability. All right, or 1 to the left. And there, number 4 there is the factorial button. So if you hit 4 from that screen, you'll get your 5 factorial, and then just hit enter, and that's 120. So let's go with that again. You hit the number you're going to do, and to get that factorial symbol, that exclamation point, you go to math, and you can go right 3 or left 1. That's what I was thinking, going left 1, and number 4. So hit the 4 or go down, move it down to 4, however you want to do it, and that'll get it to you. Hit enter. Okay, so it's just using your calculator to do that, because you might see that symbol on the practice quiz and tonight's homework. Okay, so here's just a quick example of this problem like this. Okay, just another way to use it. 8 factorial means 8 times 7 times 6 times 5 all the way down to 1, and it's divided by 5 factorial. Well, since I have a 5 factorial, I stopped here instead of going 4, 3, 2, and 1. Since these two are the same, I can go ahead and just cancel those. So all I have to do is 8 times 7 times 6, which should be, what, 42, 7 times 6 times 8, all right? Which is what, 300 and something, all right? 8 times 7 times 6. So you could do it that way, 336. Yeah, why did I say 400 something? My calculator up here is not working too well. Okay, or you could actually just put that in your calculator. Okay, we could just do 8, math, probability 4, divided by 5, math, probability 4. And we'll get 336. Now, if you get more than one number with that factorial sign, you'll probably have to put parentheses around it. All right, so just to be aware of that, wanted to show you that. You'll see that symbol in a problem or two for homework or the quiz and practice quiz. Okay, so summation notation. Okay, it's a convenient way to find partial sums. The sum of the first n terms of a sequence a sub n is represented by using the Greek letter sigma. So that symbol there, that weird looking E, is a Greek letter, and we call it sigma, and that represents summation, or finding the sum of so many terms of a sequence. So that's what we're doing today, is we're going to find 3, 4, 5, 6 terms of a sequence, and then we're going to add them up. Okay, so that's what we're doing today. Here's an example of that summation notation. Okay, so we have our summation sigma, and then we got I equals 1, and then n. All right, and then here's our rule, a sub I. All right, so this is what we call a series. When we add the terms of a sequence together or do a summation, we call it a series, the sum. It is a finite series because it is the sum of a finite number of terms of the sequence. We're only doing so many of them. We're not doing all of them because that's an infinite sum. We're just doing a finite one, finite series. So the letter I is called the index. So that's whatever we're using. They'll use any letter for you. They'll use I's and J's and K's and X's. It doesn't matter. So, but that number or letter, is called the index. And whatever it equals, in this case 1, we call the lower limit. So that's where we start for our n value. And then the number up above, the sigma, is called the upper limit. Okay, so you're going to have a number here and here. So whatever number's here at the bottom, the lower limit, is the first number we'll put in for n into our rule, or in this case, we'll put in for I. And the top number is how far we go up. Like if it's 1 to 5, we'll do the first 5 terms of the sequence, and then we add them all up. So it's an extra step from what we did on Monday. Okay, we're going to find the terms, and then we're going to add them. That's that extra step when we see this notation. Okay, so in this problem, if it was 1 and a 5, let's say, it would be the first term, which would just be 1, plus the second term, which would just be 2, because we're just putting whatever it is that, all right, so it'd be just 1 plus 2 plus 3 plus 4 plus 5, and we'd add those up and get our answer. Okay, but they're not all quite that easy. Okay, so we're just going to look at a couple examples. I'll go through them, and then you'll have your assignment. All right, second to last assignment as far as homework. Your practice quiz next Monday would be your last assignment, and then the quiz will be your last quiz and last grade next week. Seniors are graduating. That is awesome. Okay, so we're at example 1 here. We're evaluating the series. That means we're going to figure out, it looks like 4 terms here. First to the 4th term, we're going to find those 4 terms, and then we're going to add them up. All right, that's what it means when you say evaluate the series. So let's move this down till we get to the next one. Give ourselves some room. So we'll find the first term, which means we're going to put 1 in for I over 1 plus 1. Remember, we're going to add them. So plus. Now the second one would put a 2 in for it. So we go right in order. So 2 in for I, and then 2 plus 1. And then add the third term, which would be 3 in for I, over 3 plus 1. And then add the last term, because we're only going from 1 to 4. So we put 4 in for I. So that's just substituting in. Then we find each answer, and then we'll add them up. So 1 over 1 plus 1 is a half. And 2 over 2 plus 1 is 2/3. 3 is not very good, is it? Got to relax here. All right. Third term is 3 over 3 plus 1, 4. And the fourth term would be 4 over 4 plus 1, or 4/5. So then I add those up. Okay? And you can just put that in your calculator if you want. Remember, when we use this calculator, we're putting parentheses around fractions. So parentheses, 1 divided by 2 is our 1/2, plus 2 divided by 3, plus 3, oops, forgot my parenthesis, 3 divided by 4 for 3/4, and then 4 divided by 5. And then I like to leave it as a fraction. So remember, to change a decimal to a fraction, you hit Math and then enter twice. So 163 over 160 is the sum of that series using our summation notation. So we got our sigma. I is 1 to 4. So remember, lower limit, we start at 1 for I. Upper limit, we end with 4 in for I, and we find all the answers in between. So we put 1 in for I, 2, 3, and 4 in for I in both spots. Find each answer, and then remember to add them up to finish it off. Every year I have some kids who forget to add them up. They do all this right, and then they go on to the next problem. So don't be in a hurry. Okay? And then the second one, we'll just get rid of that shade and extend it. All right, so we're going to evaluate this one. Okay, now our lower limit is 2. So you don't always start at 1. You start at whatever they give you. Sometimes they'll start at 0. Okay, so whatever that is the first number you put in. In this case, for x, I said they could use any letter you want for the index. And this is where we stop substituting in. So we're going to substitute in 2, 3, 4, and 5. So another problem with 4 answers first, and then add up those 4 answers to find the answer to the series. Remember, when we're evaluating this series, we're adding all the terms up of the sequence. All right, so this would be -1, and we're putting 2 in for x to start, so a 2 for that exponent, and a 2 in for that x. Okay, and then plus -1 again, but this time x is 3. And remember, 3 goes in for x in both spots. And this is squared every time. That doesn't change. Plus -1 still, but this time x is 4. And then our 5. So x is 5. So there's my 4 problems. I got to find those 4 answers and then add them up. So remember, 1 squared is 1, positive, and 2 squared is 4, so that's 4. -1 cubed, remember, is 3 negatives, odd number negatives, so that's -1, and 3 squared is 9, so that's a -9. -1 to the 4th, again, even number there for our exponents, that's an even number of negatives, +1, and 4 squared is 16, so this would be +16. And -1 to the 5th, another odd exponent. So that's -1. And 5 squared is 25. So that's -25. So I like just to do the positive ones together. 4 and 16 is 20. And the negative ones together, -9 and -25 is -34. So the sum of this series would be 20 minus 34, which is -14. So that's how we evaluate a series with this summation notation. Okay? So again, this could be any letter. It'll be in our rule. So we see an X twice in this rule. So we're going to put 2, 3, 4, and 5 in. This upper number, upper limit, tells us what's the last number to put in. So find that 4 answers, 5, 6, whatever you have to do, and then add up your answers to finish or evaluate the series. So hopefully that's pretty easy for you. Okay, your assignment is this next slide. It's page 936, numbers 48 to 60 even. You do not have to do number 58. I'll post a picture of that on Canvas. I also figured out how to get the picture of that page right here on this slide. Just hit extend page so you can see it. All right. And I guess I should leave it there, but it's due Thursday, tomorrow, the 7th. Okay. I guess you can't see it, it's so big. All right. So I'll post a picture of that on Canvas. It might be easier for you to see. But again, I appreciate you guys working and finishing strong here. We're almost at the end. I know what's happened has not been fun for you guys. You miss each other. I'm sure you miss me, your favorite math teacher ever. And I miss you guys. So please finish strong. I'm real proud of you guys. Hope you have a great day. Remember, you either get the bear or the bear gets you. Look good, feel good. You are good. You have a great day and enjoy.